circuit of the loader, conveyor, splitter, and chipper. We are looking at another group setup of the chipper, and we're just going to go through and explain how we're going to go about getting the different gallons per minute and the horsepower requirements. Pretty simple setup right now. We have the reservoir down at the bottom. We're setting our relief valve pressure for 2000 psi, and that's going to give us more options on our ISO clean code, and that's kind of as a group what everybody had decided to use. For horsepower of the motor, we went with 40 horsepower. We have added up all of the group's horsepower requirements that they said they need. You can see for each one what and it came to 38 horsepower. We didn't want to shortchange ourselves, so we came up with 40 horsepower. As far as for the gallons per minute of the pump, again, what each group had told us what they would need to run their circuit, we added them all up, and we wanted to use a 30 gallon per minute pump. Danny's going to explain how we go through the math of using all the circuits and what they're going to need for gallons per minute and horsepower.
So I'm going to explain how we took our power circuit and distributed everything between all the four other branch circuits that came off of us. So we started, everyone gets 2000 psi. Jason explained earlier how we came up with that. But just so no one gets confused, we kind of related it to electricity. The psi in this case is the voltage. In a parallel circuit, hydraulic or electric, the voltage or psi is going to stay the same throughout every branch. So everyone's going to end up getting 2000 psi. Now GPM is different. The GPM or flow rate is like our current. It's going to get divided up between each rung. Each rung will pull what GPM they need. So as you can see in the picture, the first rung is going to need 3 GPM, the second will need 7, the third will need 12, and the fourth will need 8. When you add those all up, you get 30 GPM. We set a flow meter in here to tell you how much GPM we're getting. It should be 30. Okay. Now we're going to have Logan explain our filter and
all the fluid goes through these four circuits. It goes to the filter, the return filter, and it goes back to the tank and recycles all the way through the four circuits again. To determine the tank size, we took the total GPM, just 30, and we could multiply it by 2 or 3. In this case, we did 2. 30 times 2 is 60, and that's the size of the tank, and we did that for mobility purposes.